Alright, for this video we're going to be talking about exponent and logarithm properties. You've seen exponent properties pretty much ever since Algebra 1, but it can't hurt to go over it again. When you have two bases being multiplied to each other, so two of the same bases, we're just going to call it base B for right now. If you have two bases that are being multiplied to each other, you just add the exponents. If they're being divided, you subtract the exponents. If we have a base being raised to an exponent, and then that's being raised to another exponent, you multiply those exponents. And we know that anything to the 0 power is 1, and anything to the first power is itself. Now, I'm sure you remember from class me saying logarithms are equal to the exponent. That's basically because logarithms follow the same properties as exponents. That means if we have, say, log of some base of m times n, that's equal to log base b of m plus log base b of n. So we have two of the same bases with exponents being multiplied to each other. That means we add them to each other. Same goes for division. If we have a log base b of m divided by n, that's the same thing as subtracting. Whoops. Log base b of m minus log base b of n. Alright, if we have an exponent being raised to another exponent, the equivalent to that in logarithmic form would be our log base b of some n being raised to another exponent. So we have our log being raised by an exponent, and an exponent being raised by an exponent. That means we can multiply them. So we're going to bring this exponent of n out to the front and multiply it to the original exponent. So we got n log base b of n. Alright, and these are all coming from these properties over here. We're not making anything up, we're just rewriting them differently. And we have log base b of 1 is always going to equal 0. B to what exponent equals 1 is 0. And then log base b of b equals 1. Alright, these are just the basic properties of logarithms. We're going to get into some a little differently in the next slide. Okay, now we're going to use those logarithm properties we just talked about. We're going to write this logarithm as a sum or difference of logarithmic expressions. So, first thing off, we have division here. So that means we're going to be subtracting. This is going to be log of x squared minus 2x plus 1 minus log of x squared minus 9. Now, first thought would be, hey, I think we're done. Woohoo! But let's see if we can factor this out a little bit. So that's x squared minus 2x plus 1. That can be factored to x minus 1 times x minus 1, which is x minus 1 squared. And this guy is log base x x minus 3, x plus 3. Okay. Using the log properties, if we have a logarithm being raised to an exponent, we can bring that up front. So I'm going to read that as 2 log x minus 1 minus. So we're subtracting this whole term. So I'm going to put in, and we're multiplying on sides, so that means we're going to be adding two logarithms. So I'm going to put them in their own brackets. Alright, so far so good. Now, we can either leave it like that, or we can distribute this negative to both these terms. Either way, you'll get the right answer. So I'm just going to distribute those negatives just to make it look nice and pretty. And there we go. There is our final answer. So pretty much we just rewrote that logarithm using the properties and we expanded it completely. Now it's in the sum or difference of logarithmic expressions. Alright, here is pretty much the opposite direction of the last slide. Here we're writing this series of logarithms as a single logarithm. So we're going to use our properties from before, so go in the opposite direction. So let's start right here. We have 1/2 times the natural log of x plus 3. Well, the only time we had a number being multiplied to the outside was when we have an exponent up here. So I'm going to rewrite that using that property. So natural log of x plus 3 raised to the 1/2. Same thing goes for a 1/3 x plus 2. The natural log of x plus 2 raised to the 1/3 and minus natural log of x. Alright, now we saw in class when we have a fractional exponent, that's the same thing as a root. Okay, so we have the natural log of x plus 3 to the 1/2. So that's natural log of the square root of x plus 3. Same thing for the x plus 2 to the 1/3. We have natural log of x plus 2 inside a cube root. Alright, now we want to combine all these subtractions. Subtraction means we're going to be dividing. So we're going to have natural log of x plus 3 over the cube root oops, I think I might have messed up something here. That's supposed to be a 2. Okay, and we have natural log of x on the bottom. Okay, then we have one more division. Since this is subtraction, we're going to divide one more time. This is the natural log of x plus 3, x plus 2, and then I'm going to squeeze that x right here. And there we have it. Alright, after seeing this video, I think you should feel comfortable trying these numbers on page 382, 21 to 24, and 42 to 44.